We now turn our focus to finding horizontal asymptotes. The line y equals k is a horizontal asymptote of a function if, as x approaches infinity or negative infinity, y approaches k. So horizontal asymptotes have to do with the function values, whereas vertical asymptotes have to do with the input of the function. Horizontal asymptotes are asymptotic at the ends of the graph. That is, the far right and far left of the graph. The function approaches k for very small or large values of x as shown. So when we say very small values, I'm talking about going down to negative infinity, and very large values obviously going to positive infinity. So we're looking at the end of the graph and how it's approaching or leveling off at this value y equals k. A rational function can cross its horizontal asymptote. The ones that we're actually going to graph in this course most likely will not cross the horizontal asymptote because we're going to use transformations of 1 over x and 1 over x squared, but in general the rational function can actually cross the horizontal asymptote. The location of a horizontal asymptote is based on the relationship between the degrees of the polynomial functions in the numerator and denominator of a rational function. If we have r of x is equal to some polynomial in the numerator where we have a sub m x to the m plus a sub m minus 1 times x to the m minus 1 plus other terms down to a sub 1x plus a sub 0, and the denominator is b sub n x to the n plus b sub n minus 1 x to the n minus 1, and so on to b sub 1x plus b sub 0. As x goes to infinity or negative infinity, r of x behaves as r of x equals a sub m x to the m divided by b sub n x to the n. That is, the leading term kind of takes over, because if you think about exponents and the way they grow, and so if this is the largest exponent, that value is going to far exceed whatever we can add to it with smaller exponents. And so what happens as x gets really, really large, the behavior of this graph is really going to depend on the quotient of the two leading terms, very much like a polynomial function, right? That leading term, the degree and its coefficient, determined the end behavior of a polynomial function's graph. And so there are 3 ways that those degrees in the numerator and denominator can relate. The first case is if m is less than n. So that is the degree in the numerator is less than the degree of the denominator. Then r of x has a horizontal asymptote at y equals 0. And that is because if we have a larger exponent in the denominator, that value in the denominator is always going to be larger than whatever the number is in the numerator. And if you remember anything about fractions and their relationships, when we divide something by a larger number and increase the size of the denominator, it's going to actually go to 0. Now, the second case is if the degree in the numerator equals the degree in the denominator. That is, if m equals n, then r of x is a horizontal asymptote at the quotient of the leading coefficients. That is that y is equal to a sub m divided by b sub n. So if the degrees are equal, basically everything can be ignored except the quotient of those leading coefficients. Now if m is greater than n, so the degree in the numerator is greater than the degree of the denominator, then r of x does not have a horizontal asymptote. Really important to note is that a rational function will have at most one horizontal asymptote. So in these examples, we're just going to determine the equation of the horizontal asymptote, and all we need to do to determine that is to figure out the degree of the numerator and denominator and their relationship is which one's greater, larger, and are they equal. So in the first example, we have a function that is equal to 3x plus 2 divided by x minus 1. The degree of the numerator is what? It's 1. The degree of the denominator is also 1. So in the case when they're equal degrees, the horizontal asymptote is the equation y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator, which is 3 divided by 1, or 3. Now how can you use your calculator to determine this? You could enter the function 3x plus 2 divided by x minus 1 and look at the table. As x gets very, very, very large, what are the y values approaching? And you would find that that would be 3. Part B is f of x equals x to the 4th minus 5x cubed plus 2x squared plus 7 divided by x squared plus 4. The degree of the numerator is 4. The degree of the denominator is 2. So as x gets really, really large, notice that this x to the 4 is going to overpower this x squared in the denominator, and therefore it will continue to grow and increase in value, and so there's no horizontal asymptote. So we're thinking about what is the value of y that the function approaches as x gets really large in the positive direction, or x is really, really small in the negative direction. And so we're trying to figure out how does the function behave at those extreme values of x. Part C is f of x equals x squared plus 2x minus 6 divided by x to the 3 minus 8. Here we have the degree of the numerator is 2, and the degree of the denominator is 3. So this is a case where the denominator's exponent is larger than the degree of the numerator, and the horizontal asymptote will be y equals 0.